a few more examples of type 2 integrals. Here's one. Right. So again, here you have something where you might easily just see that and go with it and not necessarily realize that there might be an issue here, okay? Because let's look at where this issue is. If I factor the bottom, I've got x minus 2 and x plus 1. So this has two different asymptotes. I don't really care about the asymptote at -1 because it's not on my interval. I'm trying to do the integral from 0 to 4, so who cares about this one? This part is fine. This part is what's causing me the problem because I have an asymptote straight in the middle of my thing. And I may very well not have seen it unless I'm paying attention and I check. So all I have to do is break this up at 2. I have the same situation as I had in one of my other examples. I'm going 2 to the left. Plus the limit 2 to the right of the next part. All right, sorry. Oh my God. S and T, right? That's what I'm trying to do. So I've sort of scrunched it up in the corner here. What I'm going to do, of course, to see both of these, I'm going to need to do some partial fractions, and then we're going to need to evaluate the integrals. So I'm just going to concentrate on the first one, and if the first one turns out to work, then I can go and I got to do the second one, because they both have to work. If either one of them diverges, then the whole integral diverges. So, but first of all, of course, I have to do my partial fractions to figure this out. And it's not that bad, right? This is one of the straightforward partial fractions that shouldn't cause me too much heartache. So I've got I've got a x plus a plus bx minus 2b. So that turns out to be a plus b, x plus a minus 2b. So pretty simple, right? A plus b equals 0. A minus 2b equals 1. If I subtract here, I'm going to get minus 3b equals 1. B equals negative 1/3. A equals 1/3. Okay, so what I'm going to do is I'm just going to, I had it in that order. I probably shouldn't have erased it before I wrote it. I'm just going to look at this. Limit as s goes to 2 from the left of 0 to s of 1/3 1 over x minus 2 minus 1 over x plus 1. Yes, hopefully that's the right thing. There. Yeah. So then, what I'm going to get rid of this, if you all don't mind. So then I have the limit as s goes to 2 from the left of 1/3 of natural log of x minus 2 minus natural log of x plus 1. Okay, evaluate from 0 to s. So if I actually want to make sure, double check all that stuff, I'm just going to take the 1/3 out here just to make my life easier. I can put those two together just because it's going to be a little bit nicer to evaluate the integral. Maybe it won't be, maybe it will be. I don't have to do it this way. It's fine. Either way, I'm going to do it that way. So what do I have? I have 1/3 times the limit as s goes to 2 of natural log of s minus 2 over s plus 1 minus natural log, okay, I put in 0, I get natural log of absolute value of negative 2, so that's just L natural log of 2. Okay, but what happens here now, I'm going to do this, right? All I have to do left is the limit. If I put that here in here, I'm going to have natural log of 0 over, what, 3, right? So that's natural log of 0. This goes to negative infinity, right? So this diverges. It's off to negative infinity. So the first one diverges. It means I'm done. I don't have to do the next one because the whole thing diverges. So that's it. Okay? So let's look at another one. It's slightly different. We have to think a minute on this one. But it's not too bad. This is a nice, easy integral. I think when we get there, it's quite okay. Cosine theta over square root of sine theta d theta. Okay? Here, my problem is going to be at 0. Because sine of 0 is 0, and cosine of 0 is 1. So this is going to be like a 1 over 0. That's my infinity. There's not a problem at pi over 2, right? Because that's just going to be 0. That's fine. So, and there's not a problem at any point between 0 and pi over 2. By the way, that can happen too. Like it can be messed up at the endpoints and in the middle. We'll do one or two like that in the next video. Okay? So you have to kind of be careful with all these. So my problem is at 0. I'm going to take t to 0 from the right because I'm at the bottom there. So t pi over 2 cosine theta over square root of sine theta d theta. All right, so I'm going to make a u substitution here. Obviously, u equals sine theta is a good one to make. By the way, that's a good point. I should be making that point right now. You may when you change the, if you change the limits, you have to be careful with the fact that this is limit. That needs to change too, okay? So be careful. I would say the easiest thing to do, because it can kind of get tricky, especially when there's infinities going on, rather than change the limits, just go ahead and go back to the original variable and then take the limit with the original variable. I would not suggest changing the limits when you do these. It's just too easy to screw it up. So, right, this is going to be, the integral of du of the square root of u. So that's u to the minus 1/2, right? So my integral is going to be u to the 1/2, right, with a 2. So it should be 2 square root of sine theta from t to pi over 2, right? Because this can be 1/2, this thing minus 1/2, that 1/2 kills that. Okay, that gives us this. So now what I have is I have 2 times square root, let me put the limit in there here. 2 square root of sine pi over 2 minus 2 square root of sine t. Well, really, as I take t going to 0, of course, sine of 0 is 0. So this just goes to 0. I'm left with 2 times the square root of sine pi over 2. Sine pi over 2 is 1. So my answer is 2. So this integral nicely converges to 2.